Hello, one and all. Bienvenue à tous. If you're tuning in live, thanks for making the time for us in your busy day. If you're watching this later on YouTube, thanks for stopping by. Whichever way you're joining us, welcome to Postmedia's 7th season of Driving into the Future. Today's panel is Rethinking Road Safety in the Age of AI, and I'm David Booth, Senior Writer for Driving.ca, and your host for today's panel. We stand at a crossroads in road safety in Canada. While the number of collisions and injuries have dropped in recent years, the number of deaths on our roads remains stubbornly high. In fact, the number of fatalities in 2023 was exactly the same as it was 10 years ago. And yet, much of our industry hopes that by 2050, we will be on a road to zero in which no one is killed or seriously injured in road crashes. The question, of course, is how do we get there? Cars will have to offer better safety technology. Collision protection will have to be improved. Drivers will need more and better assistance. And eventually, we hope that autonomous vehicles will help reduce the number of collisions on our roads. But how soon can we get there? How will we make our cars more protective? Perhaps most importantly, especially since we've been promised self-driving is right around the corner for years now, how soon will cars be hand-free? And will the robotaxis of the future really prevent all accidents? Tough questions all. Lucky for us, we're joined today by 4 experts who are going to illuminate us. First up is Åsa Haglund, Global Head of Volvo Car Safety Center. Derek Caveney, Senior Executive Engineer at Toyota North America. David Kidd, the Insurance Institute for Highway Safety's Vice President for Vehicle Research. And the tough name, Professor Krzysztof Czarnecki, Research Chair and Associate Director of the University of Waterloo's Center for Automotive Research. Welcome to you all, and thank you so much for joining us today. Before we jump in, let me welcome all our viewers and let them know what you will be trying to answer some of the questions, excellent questions that you submitted. Åsa, thanks for joining us today all the way from Sweden, really appreciate it. Diving right into it, your company, Volvo, essentially invented and popularized the concept of the safe automobile. So considering all the research that's been conducted by your safety center over these many years, what does Volvo consider the most important thing about keeping people safe on the road?
Well, thank you, David, for having me, and I'm really happy to join. And I would say, yes, I agree. So Volvo Cars has been drivers in driving safety development since we actually started the company. And the idea we started on was that, hey, cars are driven by people, hence they need to be safe. It all needs to be about safety. And I would say that the key to driving safety then is to understand the real world, all the situation that you will end up in driving a car or riding in a car or being around a car. If we can understand all these situations people will end up in and kind of grasp how their mind and body may react to that, then the rest becomes an engineering task, right? It becomes a problem to solve, like how do we offer the experience you want while being safe? But the key is to understand, and that's why we've been collecting data about real world accidents and incidents since more than 50 years now, and have built this huge database for understanding real world accidents, as well as doing research on how do we protect people and keep them safe. And the good news, referencing your intro of where we are going here, I think the good news here is that all of these aspects are improving, right? We are increasing the data we can collect about the real world and how we react to it. We are developing technologies so that things can improve. And we are even developing the tools so that we can verify that what we do is improving. So,
have you ever counted how many accidents that Volvo is it like 1,000? Is it 10,000 over the many years? Has it ever been?
Yeah. So the accidents we've been researching and collecting is more than 50,000 accidents, and we actually have more than 80,000 people involved in these accidents that we've been looking through. So it's not a handful; it's actually a wide range of of crashes that has happened and people that have been involved that we've learned from.
Thanks very much. David, the Insurance Institute for Highway Safety just announced its safest cars for 2026. So our timing today seems impeccable. The IIHS's testing is also the most rigorous in North America, and you've been doing it longer than I think any other independent organization. So who better than you to tell us what makes for the safest car? What in your eyes separates using IIH's own terminology, a top safety pick from a good, acceptable, or marginally rated vehicle? I suspect that all those tuning are very interested in finding out what they should be looking into for a new car.
Yeah, first off, thank you, David, for having me on the show. I'm happy to share kind of our perspective on safety. And yes, we did yesterday release the latest list of vehicles that got our most coveted awards, which are Top Safety Pick Plus and Top Safety Pick. And these awards that we give out every single year are for new model vehicles. And they are a simple guide for indicating which vehicles are the safest per our test. And what do they consist of? Well, we test vehicles, their crash worthiness. So if a vehicle's in a crash, how well does it keep the occupants safe? How well does it hold up? And we test in different modes. So and they typically are complementary to existing federal regulations in the United States, but they often push the envelope further. And over time, we've continued to ratchet up how difficult those tests are to continue moving the needle forward when it comes to vehicle safety. So like I said, we have crash worthiness in the mix. Back in 2013, we started integrating crash avoidance technologies. So technologies that will, for instance, automatically brake the vehicle if you're about to rear end someone in front of you, so that you could hopefully not be as severe of a crash, or you'll avoid the crash altogether. And so we do testing for that technology, how that technology responds to pedestrians. And so all of these different tests, we rate the performance from good all the way down to poor. And that Top Safety Pick and Top Safety Pick Plus basically wraps up all of those, the performance in all those different tests into a single award. So if I'm going out to buy a car and I want some sort of information about what car is the safest, if it has that badge, Top Safety Pick or Top Safety Pick Plus, then I know this vehicle does well across the board in the different ways that IIHS evaluates it. If it's Top Safety Pick Plus, then it's basically got the latest and greatest in terms of helping to keep you safe as an occupant, as well as your other members of your family or travelers, as well as technology to help keep you out of those crashes as well.
Well, thanks very much for doing the work, because I know that every time we write an IIHS story, it's usually our top rated story for the day. Really is. Okay. So thanks. Derek, thanks for joining us. One of the least understood questions in the marketplace is what constitutes a self-driving car? More specifically, where do autonomous cars sit right now? Are we at level 2? Are we at level 3? Are we somewhere in between? And what are they capable of doing? And perhaps most importantly, what are they not capable of doing?
Yeah, thank you, David, and good morning, everybody, and thank you for having me as well. It's an exciting time to talk about driving automation, really. Self-driving and autonomous vehicles are actually on North American roads today. You can take rides in a number of U.S. cities with Waymo and Zoox and others, and you can experience these great technologies as they're evolving. But they shouldn't be confused with driving assist systems, or as you mentioned, SAE level 2 or SAE level 3 systems, because they're quite different. Self-driving or autonomous vehicles, they have to handle the entire driving task from start to stop of that ride. And so you see these technologies today just in private robotaxi or robo-shuttle services. However, in automotive, in personally owned vehicles, like some from Toyota or Volvo, you'll see these driving assistance systems which can help you at different times of your drive. SAE level 2 is that driver assistance where you need to be a supervisor all the time as a driver and be ready to take over at any time for when the system can't handle that situation. It reaches the limit of its capabilities. In SAE level 3, that's when you can actually take your eyes off of supervising the system at all times and allow the system to drive you with your eyes off the road. But you still need to be awake and available for taking over the driving task if the system reaches its limit. So it's exciting because we do have all these technologies on the road today globally. In North America, we have these self-driving and autonomous vehicles, but they do have even their own limitations, even the top levels of driving. And what we're seeing is that these capabilities are growing all the time. You may have seen that Waymo just announced that they'll expand their ride hailing service to Detroit this year. And that's where I'm sitting today. I'm in Detroit, Michigan. And we have winters that are very similar to those Canadian winters that you have for many of your listeners. And to be confident that you can launch these self-driving technologies in a winter condition now shows the evolution of these technologies that are leading to a truly self-driving vehicle available in any type of driving condition.
Well, yeah, I've been to Detroit. I've also was born in northern Quebec. It'll be there's a difference, but we'll see what they could do. Krzysztof, I think by now most of us understand that self-driving cars will only become a viable alternative if they can learn how to drive. Until now, indeed, until I read one of your recent papers, I assumed the major learning tool would be all the data being gathered by existing self-driving fleets like Waymo and Tesla. But I believe you're suggesting that social media, those crazy crash videos we see all the time, are more efficient as learning tools. So can you explain to us how do we teach cars to drive themselves and how YouTube videos help us do that?
All right. Thank you, David. Fantastic question. I think everyone in the audience should kind of keep this in mind, that artificial intelligence can be great, but it's only as great as the data we feed it. So the data is really the limits of what AI can do. And when you think about driving, like 99.9% of driving is very repetitive. Maybe some things are less common than others, but really, if you have a fleet of even a few thousand vehicles, you're gonna get the 99.9% in a given area captured, and your AI will perform pretty well there. The trouble is that the level of safety that we need requires additional, what we call additional, at least 3 nines, or even more. I mean, like total of 9 nines. So this is a very high mark to hit. This is like what humans do. It takes, like, if a human drove every day, say for 8 hours a day, it would take something like 25 lifetimes, according to Canadian statistics, for an average driver to actually cause a fatal accident. That's a very high mark to hit. And AI is not near there. And why? Because there's this fraction that I said, like we can do 99.9 covered in the data of the situations, driving situations that AI needs to know about. But that fraction of a percent, these are the edge cases, the things that can happen on the road. And there's like endless number of them. I mean, and current self-driving cars have tapped into this trap already. So we have examples of self-driving cars driving over downed power lines, because that's something new to them. Obviously, that's dangerous. Or not knowing how to behave in floods, particularly flash floods. That happened to Waymos in Phoenix. Or basically have some weird things on the road. People transport all sorts of things, like maybe a tree on a trailer. And there was a case where a Waymo was like snaking around a trailer with a tree because he was classifying as a tree, as a trailer, as a tree, as a trailer. So these are these edge cases, and you can always address these things that but we get this with a fleet of vehicles, maybe of there's something like 3,000 or 4,000 Waymos. That's it. That's the fleet. But we have millions of humans, so that's where the edge cases harvested from human experiences are interesting. And how can we use that in future? We can use that to seed generative AI to basically produce like deep fakes of these edge cases and even interactive deep fakes. So that's pretty exciting. So we can have these simulators that will throw these crazy situations in these cars. But that's still future.
Well, I'm sure all those people trying to do viral videos are really happy that they're contributing to safety. I mean, they'll tell the cops that next time when they get stopped. Osa, reading through a bunch of your company's safety papers, I noticed that one of the primary concerns regarding crash protection is maintaining the position of the person in the car. How does this affect injury prevention? What do we do about people who are smaller or larger than the norm? How do we make it work for everyone?
Right. So that is really the key. How do we make it work for everyone, right? Because ultimately, safety and vehicle safety, and I know we do all these crashes to see how the cars behave, but what it all comes down to is, of course, to make sure that whoever is in that car steps out fine, right? And for that, we need to make sure that we protect people in the situation they end up in. So, and we know from all that real world research we've been doing, we know, first of all, I think we all know that people are different, right? It's just look around. We are all different. We have different tolerance to violence to our bodies, depending on age and posture and gender and whatnot. So I think what it is about is, first of all, knowing and taking into account the fact that people are different, and doing the research, the biomechanic research on what can the human body take in different situations. And we should know that we can be injured both by forces applied to us, where we break bones, but acceleration can also hurt us. If you think about I think a concussion is a good example, where if you hit your head, we all know that even if the skull is not fractured, you can still have a concussion, right? Because the brain won't stop just because the skull does, and then there is an internal collision. So we have to consider what accelerations do we apply to the body and what forces is applied to the body, and make sure all of that stays below the limits of what people can take. And then you ask, so knowing that people are different, we sit in different postures, we experience the crashes in the world are different. Well, what we do with that is we need to take all of that into account as we design the cars, right? So what we want to do is to make really robust system, a seat that will support you in whatever position you choose, but that will also be comfortable and promote a good position. A seat belt that will protect you. And our very latest innovation, the multi-adaptive safety belt, I think is a good example, where we actually bring in the what we can learn from internal sensors on who is in the car, with what we can learn from the external sensors, knowing like what is going on around the car. And then in that belt, the ability to adopt the force depending on the violence you are going to face and who you are is built into the belt, so that we can actually adapt it better for a more individualized protection for whoever is in that seat. So I'd say all that research comes down to understanding what happens, how is position and variation in human bodies impacting the outcome, and then we bring it into how do we design for it.
Just quickly, what about children? I mean, they're the tiniest. We put them in child seats. Parents shopping for child seats, what are they looking for? What does the child seat need to do?
Well, so it's easy to, it's first of all, it's important to remember children are not just small adults, right? We all know whoever has watched children grow, we know that they start with a head much bigger in relation to their body than we end up with, and so they are different, and you need to know the biomechanics and whatnot of children then. So having researched that, Volvo also introduced the first, as a car manufacturer, the first ever rearward-facing child seat, as we realized that with that big head and quite weak neck, the very best way to protect the child is actually to place it rearward-facing, with a good support for head and neck and back, actually. So, of course, when a child is young, when the head is still, so to say, bigger in relation to the body than later, and while the hips are not as developed, the hip bone I then speak of, I would argue what you're looking for as a parent is something, a child seat that can protect your child by keeping head, neck, and back in line. So I would look for a rearward-facing child seat for the very young children. That's before they can kind of sit up and use the car restraints. Then, of course, when children grow older and once, can sit up in the car restraints, what you look for, I would say, is whatever child seat that brings the child up to a height where the safety systems of the car is actually able to help them. It's just, they just need an adapter. They just need something to sit on so that the safety belt ends up on their shoulder and make a good support for the hips, where the belt can also take support in the hip area. Least complicated, just adapting to what the car is already designed to do for them, I would recommend.
Thanks very much. I'm sure some of the people listening are really want to hear something so simple. Derek, how do we make advanced driver assistance systems more palatable to people? On the one hand, pretty much everyone loves adaptive cruise control that keep you a set distance from the car ahead. On the other hand, I don't know anyone who doesn't switch off those infernal lane departure warning systems. I guess I'm asking, how do we make these advanced safety systems more acceptable to the average driver?
Yeah, David, actually, just hearing Ulsa's answer for crash worthiness, it's very similar for crash prevention. It's very personalized. And I think that's the answer for how we get to the next generation of acceptability for advanced driving assist systems. Today, our knobs are really limited to like sensitivity and timings of warnings or supports. But as we're in the age of AI now, we're going to be having more AI agents in the car with you to know how Derek likes to drive or David likes to drive and what context they need those warnings. And so it's going to become very contextual and personalized, that for the scene that's happening around your vehicle as you're driving, we provide the appropriate level of support for you, the driver in the seat today. I will mention something, though, about the lane departure warning. And this is a shout out to our friends at IIHS. They actually did a study 8 years ago and then another one a couple years ago where they showed a huge change in acceptance of lane departure warning from something like 50% to upper 80s now, that people aren't turning it off, lane departure warning. And I think that that's a sign of automotive manufacturers adapting to the feedback of their customers and the safety benefits of these systems to make that balance between safety benefit and annoyance. And I will say, I think a personal opinion, a lot of that has to do with the addition of haptic feedback to our customers and fewer audible beeps and buzzers to the cabin. That's my own personal assessment of the situation. I think that's helped us get more acceptability of that lane departure warning from our customers. But I think we're going to go even further now with that kind of contextual, personalized feedback for the particular situation that the driver is in. So I think you're going to see even more and more acceptability of these systems and more safety benefit from it.
I'm with you on the haptic over the beeps. Absolutely, absolutely. David, one of the more interesting papers from the IIHS that I saw recently dealt with the unintended consequences of red light cameras. While they were preventing collisions at intersections, they were causing more rear-end collisions as those behind were caught off guard. What does this mean for the future of safety? Are we damned if we do, damned if we don't, no matter how much safer we try to make automobiles? Or could artificial intelligence game out such scenarios and eventually offer alternatives?
Yeah, I think within any safety countermeasure, what you're looking for is reducing harm, right? So when it comes to safety cameras at intersections, we're trying to prevent people from running red lights and getting into those right angle crashes, which have typically very severe or fatal outcomes, right? So yes, by having those cameras, you may have people stopping short or having heavy braking. That leads to increased chance of rear end crashes, but those aren't as severe. Those are not necessarily going to end in a fatality. And what our recent research showed that we have right now, pretty much every single new vehicle in the market that you can buy has automatic emergency braking. And so that technology is starting to penetrate the entire fleet. And so that means if you are approaching an intersection and someone stops hard, maybe to avoid getting a camera citation, and if you have automatic emergency braking and you don't realize what's going on, it's going to slow you down. And so that technology will help deal with some of these unintended consequences of some other countermeasures, right? So in and of itself, it's a good demonstration of safe systems. No one single countermeasure is going to be a panacea for dealing with deaths on the roadways. It's going to take a lot of different countermeasures that complement one another. One of the things that we saw early on with automatic emergency braking, you have a technology that will respond more quickly and with much more force than the human driver. And we saw is that, I think it was actually with Volvo vehicles, those vehicles with AB were getting rear-ended more. We don't see that quite as often anymore, but that is part of the conversation. What I put this safety countermeasure out, is it doing everything I want it to do, and is it leading to other problems, these unintended consequences? And that's things we monitor, and hopefully the intention is that the net benefit is there, the overall reduction in crashes, the overall reduction in harm, and you can tease out or deal with any unintended consequences as the technology or countermeasure matures.
Okay. Well, so the solution to technology that might cause a problem is more technology. Fair enough. Krzysztof, one of the terms that is repeated in your research is edge cases, and you already got in the first answer. If there's one thing I understood from your papers, it is that these will be the most difficult lessons for autonomous vehicles to deal with and to learn. So first, could you please tell us what an edge case is, and then give us some examples of them, and tell us, if you can, how the cars of the future will deal with them.
All right, thank you. Wonderful question. So edge cases, essentially very rare road hazards. And the best way to explain them is to see a few examples. Let's look at some examples. So what you see here are situations that you could encounter on the road. Maybe it doesn't happen every day, but it's possible, like a fishtailing trailer in front of you. It usually starts a little bit, maybe some swinging, and the next thing is the vehicle in front might actually start skidding or even rolling over. A human would pick up the signal and would pretty much brake right away with this telltale of instability or snaking. There are other situations like a sofa falling out that was improperly secured. So unsecure cargo happens all the time. Even crazy situations like someone, maybe students transporting some mattresses on top of a car, and videos of these things actually flying off at highway speeds. So let's look maybe at the next slide. There is let's just sort of step through that. There's crazy things that just you can find on the road, and there's some examples that I don't want to comment on each of them, but you see that the diversity of that it's huge. Let's just sort of step through that, and you can kind of see there's even sometimes situations where you have vulnerable road users maybe clinging on to back of a car or holding a sofa in place. These are things that just a human with the common sense can very easily recognize and respond to. The sort of first generation of vehicles, driverless vehicles that we have on the roads, they still struggle with that because these are all edge cases. Let's go to the last slide. So one situation is, like we need to just step through that. There's lots of good examples. Manholes, crazy things can happen with those. Explosions of manholes, open manholes, you can collide with them. It's mind-boggling what I've learned when actually putting together this data set from open source, crowdsourced sources. And we want to have this categorization of that. It's actually a project we've been doing that is co-funded by Transport Canada. And the idea is here that future vehicles will actually use artificial intelligence of the style that ChatGPT uses or Gemini. These are language models or large language models that have seen lots of the situations in the wild on the internet and actually can interpret and pick up many of these very subtle signals. They don't see the world as just boxes, like bounding boxes of road users and objects. They actually see the things that human would see. So that's great, and I think that in future that will be absolutely fantastic. Let's really go to the last slide, please. The last slide will show an example that AI struggles with. So
Oh, that's, no, I think that's the last one.
yeah. In any case, that example basically shows you that if you show these things to current models, they will know about these crazy situations, but they will make mistakes. And this is where the problem is. Current AI is just not reliable enough. We can do 99.99 maybe, but we still need an additional 3 or 4 nines. And that is, I think, that we will be still struggling with. Existing vehicles like Waymo use a lot of handwritten code, rule-based code to make that safe, but it takes them then months to go to the next city. And I think, we still need breakthroughs in AI to actually address these problems.
Thank you. And it might be worth mentioning to the readers, I think I'll say it, that people might think these are edge cases, but there were like 4,000 or a few over 4,000 manhole cover explosions in New York City in 1 year alone.
Yes.
So it may be an edge case to you. It's not
But not to the fleet, yes.
It's not to a fleet of cars. Okay. Åsa, staying with our discussion of maximizing crash safety, how can AI help future cars be safer? For instance, for Volvo, is it by redesigning the interior to minimize the impact on occupants? Is it superior control of airbags and automatic seatbelt tensioning that you've mentioned? Or will onboard collision avoidance systems benefit most from the increased computing power? Where do you see AI making the biggest impact for you guys?
Yeah, well, so that's really, I'm gonna go with it's really for all of them, right? And it's hard to choose, because if you think about it, I've been saying before that the way we approach safety is about, let's know what's out there, let's know what happens to people and how people can take care of that. Let's then find the best way to protect them from that, and let's launch it into a product. That's what we've been doing since 1927 when Volvo Cars was launched, right? And what we actually do with AI and with, let's say, also the sensing technology available and the core compute technology available, and now being able to package into a car, let's not forget these pieces. But with all that, what we do is we move that kind of circle of life of, let's understand what happens, let's find ways to solve it, and let's launch the solution. We kind of move that ability in itself into the cars, right? So obviously the car can now, our new platform of car, or new line of cars, are able to actually read and react to reality and learn from it as they go about, and then spread that to the rest of the fleet. So what that is going to do is, of course, it can teach us things, because we will bring learnings home. It can teach us things on how to better design interiors. For that, obviously, we need to make physical changes, but it will also teach us a lot about how people react to systems, how systems should react to perform even better. And coming back to, I couldn't agree more with what Derek was saying before, that, with all the, I really believe in the driver support systems. I mean, a driver support system does in fact have to support a driver. So the driver needs to interact with it. The driver needs to feel this is actually a helpful system. And with AI and with the sensing technology and core compute technology available, we can, of course, learn and adapt the active safety system to the individual driving, to the situation he or her is in, right? So that warnings and support becomes even more adequate to the help you need in that situation. So it's really gonna, I really think it's gonna help across the board tremendously.
Thanks very much. Derek, I know that Toyota's safe system approach includes active and passive safety systems, but you also talk about something called behavioral safety. What do you mean by that? And what can car design do to alter people's behavior? Judging by the driving habits I see when I'm on the road, that might be your toughest job of all.
Yeah, given the current, I'll say, driving environment, safe driving behaviors may be the toughest thing to solve. The U.S. Department of Transportation, U.S. DOT, they've identified the same safe systems approach, which is it's not just about safer vehicles, it's about safer drivers, safer roadways, safer, more effective post-crash care. But really, I feel that the safe drivers or safe driving behaviors is maybe the hardest piece of this puzzle. And to that end, within the National Highway Traffic Safety Administration, NHTSA, here again in the United States, they've identified driving behaviors like impairment and speeding as like maybe the top two driving behaviors that really contribute to traffic injuries and fatalities. And those things go well beyond what we can do with vehicle technology. There are countermeasures available for both speeding and impaired driving that could help reduce accidents and fatalities. However, there's a whole trade-off between safety benefit and driver acceptance. And I think if you follow these areas of impaired driving and speeding, it's always this trade-off of freedom to use the vehicle as you like versus not causing harm to yourself or others around you. So that's where changing the mindset around safe driving, that safe driving helps everybody, would be beneficial, but still the hardest problem to solve. And I'll give another shout out to IIHS again, to David here, that they've already identified speeding countermeasures as part of their next Top Safety Pick Plus program. So it'll be through regulations from the government or through assessments through our friends at IIHS or others that can drive these systems that help adapt that behavior to a safer mindset.
Okay, that's a lot of shout outs to you, Dave. Well done. In the future, will AI help the IIHS test the crashworthiness of cars? Would it help test more cars, test the same cars more often, or allow you to conduct even more tests than you do now? What is going to be the benefit of AI to your test procedures?
Yeah, before answering that question, I'll just build off what Derek's talking about. So IIHS, we have what we call our 30 by 30 strategic vision or mission, and that is to work, do what we can do, as well as work with partners to reduce traffic fatalities in the U.S. by 30% by 2030. Part of that is going to be a restructuring of the Top Safety Pick and Top Safety Pick Plus awards. The plus is going to indicate those vehicles with countermeasures that attempt to deal with these driver behavior or risky driving behaviors. Things like intelligent speed assist, things like a driver monitoring system that'll help keep you attentive to the driving task, and then impairment as well. And so that we're going to provide an incentive to manufacturers to build cars with those systems in it. Acceptance will be a key component of it, so there'll be more to come in the future. Now, going back to your original question, at IIHS, we have automation in some of our processes for taking crash test data or crash avoidance test data and coming out with a rating and whatnot. What we're done lately, where I think AI becomes more integrated to what we're doing, but not necessarily by us, is virtual testing. So we have a rear impact evaluation. Imagine you're in a car, you get struck from behind, maybe because of you stopped short at this light with the safety camera. And all of a sudden your head whips back and you're not visibly injured, but you've sustained neck strains and whiplash. It's actually a very common type of insurance claim. And we had a test around that to encourage manufacturers to have better designed seats to help prevent whiplash. We've recently updated that test to encourage better designs. It goes back to something I was talking about with car seats, having your spine aligned with your neck so that everything's in alignment, and you reduce the likelihood that your seat's going to support you, so you reduce the likelihood of whiplash. And that goes all the way to the head restraint too. We're doing the physical testing using a crash sled to replicate those type of rear impacts, but we've integrated virtual testing where we're asking manufacturers to submit to us simulated test data. And we'll be able to ground those simulations in the physical test data that we've done in-house or that the manufacturer does. And we'll be able to determine whether or not simulation data from other test cases, so it's not with the physical testing we've done, but maybe a different size occupant, maybe a higher speed or lower speed. Whether or not those simulation data, one, we believe them, and then two, if they show that seat design or that the vehicle itself would perform similarly in different types of cases that we didn't and we couldn't physically test. So AI is a part of that for the OEMs, I would imagine, and so in that manner, we are going to be encouraging the use of simulation, automated tools, and things like that and integrating that data into our evaluations.
Perfection. Thank you very much. Krzysztof, where do we stand on AI improving the self-driving cars of the future? How long before we see complete autonomy? Perhaps more importantly to we Canadians, and we touched on this a little bit before, how long will it be before self-driving cars can tackle everything a Northern Canadian winter can throw at them?
All right, wonderful question. So, we have driverless vehicles today, but only a few thousands of them in North America, and not a few thousand in China. So less than 10,000 fully driverless vehicles worldwide. And it turns out that, let's say in the US, you have mostly those vehicles rolled out in sunny weather states. Now, I'm less bullish than Derek about when these vehicles will handle adverse weather, winter well. The things that you have to worry about is, it's sure, you have impaired visibility through snowfall, but think about the roads covered in ice and snow, marking not visible. And not just that, you drive differently. You might not use the lanes the same way you use in summer. You have to worry about snowbanks, traction. People behave differently. Human-driven vehicles behave differently. You have to adjust to that. I think that these are all engineering challenges that can be addressed, but I believe it will still take a few years until we're actually comfortable there. So I don't think that next year we'll see these vehicles handling well the full range of winter weather. Maybe slight snowfall, that's gonna be fine, but not the kind of things we see here in Canada. So I believe that that's certainly one factor before we see it in Canada. Another factor is regulation. We don't really have in Canada regulations that allow robotaxis outside of pilot programs. So that's another issue. And finally, I think it's also cost. So as I explained previously, we can actually get engineering accelerated with AI. But if we need to get these 7 nines behind the 99%, so 99.999999, that requires essentially a lot of engineering, a lot of rules, a lot of safety checks that have to be hand programmed. And that results today in robotaxis companies spending upwards of $1 billion per year for development. That's crazy. So I think until we see these things really deployable at scale and being economical, I think it's going to take time. And finally, it's diffusion. So diffusion, it takes 20, 30 years often for things like automotive technologies, physical technologies to fully diffuse. So I think that for the next decades, we'll probably still have manually driven vehicles as a majority.
Thanks very much. Åsa, again, tapping into Volvo's far-reaching research into everything safety related. Of all the advancements being discussed today, either publicly or with us or behind laboratory doors, what do you think will be the greatest advance in safety in the next 5 years or so? Putting you on the spot here, Åsa.
Yeah, right. So, so I really have to come back to the fact that I believe that is data. The amount of data we can now collect on what's going on around cars, in cars, who's driving cars, etc., and the ability we have to, with AI as well, but also with more traditional methods, to learn from that will definitely accelerate safety tremendously. Also making it like, so we consider, so Volvo Cars has shared the patent for the 3-point safety belt, and we have estimated that we've by that saved more than 1 million lives. I really think with data and the explosion of learnings we can do and how fast we can iterate now, that is the way to save 1 million more. So in that sense, data is kind of a new safety belt to us. Having said that, it's also, in my mind, very important because we still have to remember that cars are about people, right? It's about being able to transport you, your loved ones in your life to go where you need to go and do what you want to do. And for that to remain at the heart of what we do, I think it's tremendously important that we make people feel safe to share their data. So making sure we don't use it to police people, but to learn and improve safety in their lives. And again, then also use the learnings to develop functionality that actually supports them in what they want to do and is not lived as limitations, basically.
Thank you. Thank you very much. Derek, same sort of question for you. Where is our money best spent on preventing the harm caused by cars?
Yeah, I'm going to build off Osa's comment about sharing a patent openly. I think a lot of money to, the best use of money to benefit society in the world of harmful vehicles and driver behaviors is to collaborate with industry, academia, and governments so that we can realize these technologies faster to market, either through appropriate regulations or assessments like IIHS, or on our own. You know, if it's not assessed or regulated, we can release those type of safety innovations more quickly because they've been tested through academia collaborations, discussed with government organizations as well as assessors. So as an example, here at Toyota, we have the Collaborative Safety Research Center, CSRC. It's a North American centered organization, but we work with a number of Canadian universities as well as US universities. And we publish all their work for anybody to use. So it's we want society to understand these evaluations of different passive and active safety research. For example, we do have work related to crashworthiness, like Osa has been mentioning, looking at human body models. And our total human body model is called THUMBS, and we published that in 2021 free for anybody to use. So any safety researcher can use THUMBS to do their analysis of the effect of a crash or impact on the human body. And it's parameterizable. We can look at how it works for an average male, average female, 5th percentile, 95th percentile. We can use these parameterizable models to actually understand the impact of that safety countermeasure on the larger population. So to answer the question about the best money spent, I think it's in the research area and it's in collaborative research. And so that we can all get to that end goal of 0 fatalities and maybe even 0 collisions much more quickly.
Thank you. So David, on to you. Lucky you, I've saved perhaps the toughest question of the day for you. We've sort of become inured to car accidents, haven't we? In the United States, where you live, 40,000 people die every year as the result of car collisions, and we never hear about them. I mean, it's not news. But on the other hand, any incident involving self-driving cars gets you top of the page headlines. So my question is, how safe do autonomous automobiles have to be before they're acceptable? Elon Musk seems to believe that as long as they're safer than human drivers, that's good enough. But that doesn't really seem to be the case. Any thoughts on this?
Yeah. First off, based upon my answer, I could be a quadrillionaire, right? Like this is a golden ticket type of answer. But this is where I sit on it. One of the biggest things that self-driving vehicles, the biggest benefits is that it can correct for some of those bad behaviors that drivers engage in that make up or contribute to a lot of fatal crashes in the US each year. So, for instance, self-driving cars wouldn't speed, right, if the law abiding. They're not going to be impaired, and you can argue that, you know, maybe they don't perceive the world as we do, whatnot, but they're not going to be, drinking and driving or smoking, or any kind of other impairment, substance that would impair your judgment. They're also a mechanism that can require seatbelt use, right? They won't work unless you're buckled up. And so all of these different type of bad behaviors or risky driving behaviors, they make up a lot, they contribute to a lot of fatalities in the US. To me, that's the baseline. We should expect that self-driving cars address all of that. And then above that, it's kind of up to the public. Do they think that, if a car comes in, addresses all those crashes, it makes a huge dent in the number of fatalities that we have every single year, that's a way that they want to get around. I think that's a big question. But I think it's important to mention, I think it's silly to wait for self-driving cars and automated vehicles to be the solution to the problems that we have today, because we know how we can address seatbelt use, right? We know how we get people to buckle up. We know how we can address speeding. We know how we can address alcohol impairment. The number of different type of enforcement-based programs, laws, or policies, as well as vehicle technologies. And so we don't have to wait until this technology is perfect, or until it is good enough to be deployed everywhere, to be able to address a lot of the problems that we have in highway safety today. So I think we need to also remind ourselves that we can deal with some of these problems now and continue to do so while the technology matures and we get to a place where we can have Jetson-like cars flying around by themselves and all that kind of stuff. But it's certainly, when you think about cars driving themselves, I mean, it's very attractive. You know, putting safety cameras at intersections, not very attractive. So it's a hard decision, right?
Thank you very much. That I appreciate for the forthright. Most people would have hit him for that question. Another tough question for you, Krzysztof, and it's of a similar ilk, and you mentioned it a little bit in your first answer. We've long been told that robot-driven cars will automatically be safer than we humans behind the wheel. But what does the data say? In fact, you have the data, I believe. What are the fatality statistics for human drivers on a per kilometer basis? And what does that mean in real life terms? How does it compare with what we know of self-driving cars so far?
All right, so human drivers are a pretty challenging benchmark for automation today. So on average, as I said, using just Canadian statistics, it would take about 25 lifetimes of driving, 8 hours a day, to be involved in a fatal accident. So most people may be, they might be involved in one most serious accident within their lifetime. We don't now when we right now compare this, let's say, to self-driving cars, particularly for driverless cars, we still don't have the data to actually make that comparison. There is only like a few thousand of these vehicles in the world, and that's not enough to actually make that comparison. The best data out there has been done by Waymo. It's a study in the operation area in California, where they showed that when it comes to minor collisions, non-life-threatening collisions, that they were doing better than comparable data from insurance. However, they cannot really say much about comparing, fatalities. On the other hand, if we take so level 2 vehicles, we do see a lot of accidents happening with those. Right now, I mean, Tesla dominates that statistic, perhaps because of also that's the most commonly used system, like, for example, the full self-driving system in North America. But I think the bottom line is that it's really difficult for technology today to match the human performance. And one thing I wanted to add is a sort of related to the previous question, that even if we, for example, were able to cut the fatalities in half using technology, let's say you have a driverless vehicle that has half the fatalities of a human driver on average, that would not be enough. You have to judge every single accident, every single crash on its own. What would a human do in that situation? Would that human avoid the accident? And if that's the judgment, then in some sense the technology, it would be a case for product liability.
Oh, well, I can't think of a single automaker that wants any product liability. In fact, they pretty much avoid it at all costs. So, yeah. So that's the end of my questions. We have some really good reader questions. As I mentioned, somebody named Joshua asks, do human-driven vehicles pose more of a risk to AI-driven vehicles, or vice versa? Derek, I'm going to go with you on that one.
Sure thing. That's a great question, and I'll kind of link to what David was saying earlier. But let me start with, I think we're kind of at a middle point now where it's kind of coming into question. If you talked to me a couple of years ago, I would say that the automated vehicles are maybe more risky to human drivers than human drivers are to automated vehicles. But now the advances with Gen AI to these driving stacks is making them pretty reliable and predictable, whereas human drivers, as David mentioned, can be impaired and unpredictable. So I think we're at that precipice now where the human drivers may be becoming more risky to the driving environment than the automated vehicles. That'd be my short answer there, David.
Thank you very much. The viewers are asking tough questions too. Michael asks, have built-in safety features caused a decline in drivers' abilities? Oh boy. Asa, David, anybody want to answer that one? Anybody got something they want to say on that question?
I mean, I'll be happy to respond. You know, one of the questions we had early on was, if I have all of these support features, even the ones that step in at the last moment to help you avoid a crash, is that going to make you complacent? Is that going to make you more distracted because I have these support features? And we did some research where we had video from drivers with cars that had this technology, and there was, across the age span or age groups, right, lifespan, they were no more distracted when driving with vehicles that had this technology than vehicles that didn't have it. And the work that we've done looking at police reported crashes as well as insurance claims data, we continue to see large safety benefits, large reductions in claims filed to insurers, as well as large reductions in police reported crashes. So even if it is the case that there is a cohort of folks out there that, you know, are misusing these technologies, or they are relying on them, over-relying on them, it's not outweighing the safety benefits that we're seeing on the population level.
Thank you very much. Okay, I got time for one more, and it was just handed to me. It was came in live. Osa, it's going to be for you. And it's obviously by somebody in the biz. We got about a minute and a half. My question is, can artificial intelligence combine with anthropometric data applications to measure a driver's body dimensions accurately and then automatically adjust the seat, steering wheel, lumbar support, and pedals to optimize comfort and safety? Pretty detailed.
Yeah, very detailed indeed. And I would say, would it be technically feasible? Yes, of course. Would it be preferable by all drivers? Is the pure measures of our body the thing that tells what is our preferred comfortable driving position? I don't think so. So I think there is the preference thing. There is the fact that on a long haul drive you need to adjust that seat every now and then. But of course, I mean, already with the multi-stage multi-adaptive safety belts, we are starting to get there where we adapt systems for who you are, right? So it's in that line, and let's see.
Okay, thank you. Krzysztof, I'm going to toss one last one to you, but you got about 45 seconds max. Myra from Saskatchewan asks, how close are we really becoming having AI managed safety addressed, especially in rural areas? Is that a pipe dream, or is AI and self-driving only available to city dwellers, or is there a possibility for rural? 30 seconds to you.
I think most of the benefits will be coming of AI coming through vehicle technology, and I said that there is diffusion time. It's going to be decades. Also, what the market would say, like even if we have that available, think about cell phone plans in Canada. They're so expensive. We don't have competition. These things might actually be expensive and not viable for rural areas. And I think that once that's diffused, this technology, then that we'll have the benefits of safety. However, driving will never be like zero risk activity. There will be still software error. There will be cybersecurity risks. And whenever pedestrians and cyclists mix with vehicles, with these metal high-speed machines, there will always be risk of accidents. And there's just no way that any technology can prevent that. But hopefully this will be much lower than what we have today.
Thank you very much. Okay, first off, I need to thank you all. David, Derek, Krzysztof, Åsa, fantastic insights. Also, I want to thank all the people who watched us. And again, you can catch us on YouTube later. I also want to thank Toyota for sponsoring this episode. And that's it for us. We're out. Thank you for watching Driving into the Future, and please log on to Driving.ca. Thank you.